Okay, so this is the exercise that I gave you before, right? So we discuss the answer together. Right, so this is a diagram below shows demonstrate the force acting on the current carrying conductor in a magnetic field, right? So the first question, right? When the switch is closed, what observation can you make? Okay, so the switch is closed now, so the current will start flowing from positive to negative, right? So here from positive to negative. So means the current here, right? For the copper wire here, the current will go inside into the paper. Okay, we go into the paper. So the observation that you can make here, okay, so the copper wire will move upward. So how do you know that we move upward? So you will use the Fleming left hand rule. Okay, so north and south. Okay, north and south, and then the current goes into the paper. So your thumb will show upward force. Okay, so the copper wire will move upward. Right, so you can check the answer. Okay, so this is the direction of the current. It will move into the paper. So north and south. Okay, so the copper will move upward. Okay, the second question, okay, asking you state the rule which can be used to determine the direction of the motion of the copper wire. So this one we use the Fleming's left hand rule. Okay. Alright, the next one we have to draw the pattern, okay, of the counterpart field in the diagram below. So this is the, okay, how you want to draw the counterpart field. Since the force move upward, so usually the counterpart field, okay, it will show downward, it will curve downward like this. Okay, so this is the drawing. Okay, so I show you how you want to draw. Okay, first from north to south. Okay, from north to south. So this is the current flows, okay, into the paper. So this one you use the right hand grip rule. Okay, so it's a clockwise. The rotation is clockwise. Okay, so you see, okay, at the bottom side, okay, at the bottom, you can see the arrow is same. Okay, for the current, okay, from the current to the from the current of the copper wire, and the magnetic fields for the from the permanent magnet. So the direction is same. Okay. So this one is we curve downward. Since the direction is same at the bottom, so we will curve downward like this. Right? Okay, so this is the drawing. Okay, and then the next one, okay, how can the magnitude of the force be increased? So the answer is increase the number of cell or current, right? Use a stronger magnet, okay, or you can increase the number of coil. Okay, so this is the answer. Okay, for the next question, all right, this one. So diagram below shows an electric motor which is supplied with a direct current. Okay, so explain why the motor will rotate faster when the current increase. Okay, so the answer is the force increase. Okay, the force increase because of the magnetic, okay, because of the magnet, when the current increase, the magnetic fields, okay, that flows, okay, for the magnetic field for the current is also increase. Okay, so the magnetic field increase means there is more magnetic field line. So okay, that's why the force will be increased because of the strength of the magnetic field for the current, okay, is increased. So the force also increase. So when the force increase, the speed will also, the speed of the coil is also increase. Okay, so 2 marks. Okay, state two other ways to increase the speed of the motor. Okay, So the second one is use strong magnet. Okay, you can use the strong magnet, or you can say increase the number of coil also can, right? So because 2 marks, so mean you want 2 points here. Okay. All right. The next one. Okay, this one is already finished. Okay. So the next one is the enforcement exercise 8. So this one already give you, right, as an extra exercise. Okay, so we discuss, right, number 35. Okay, diagram shows an apparatus set up to observe the magnetic field line produced when the current flows through a copper conductor. Okay, so this using the copper conductor. Okay, so using the copper conductor, you can see this is magnetic field. So which magnetic field pattern is correct when copper is replaced with nichrome? Okay, so when replaced with nichrome, nichrome has higher resistance, okay, compared to the copper. So it means when the resistance is increased, the current will be lower. Okay, the current will be lower. So the current will be lower. So you can see here, the magnetic field will decrease. So the answer is B, right? So until then, do you have any questions? Can you understand? Okay. Right, so we continue. Alright, the next one. So which diagram shows the correct combination? Make sure you check your answer, okay? So which diagram shows the correct combination of forces when the magnetic field due to the current in the coil combine with the external magnetic fields? Okay, so this one not to sub. Okay, this you have to draw the catapult field. Okay, so not to sub. This one the current goes. Wait, okay, this one the current is go outside from the paper. Okay, so outside from the paper, not south, outside. So the force will be upward. Okay, so this one the current goes into the paper. So using Fleming left hand rule, so north south. Okay, this one goes into the paper. The current will the catapult field will move down. The force will move downward. Okay, so you see I already draw for you. So this is the drawing. Okay, so this one goes into the paper. Okay, goes into the paper. Okay, using Fleming left hand rule. Okay, goes into the paper. So north and south. Right. Oh, this one the answer is A. Sorry, this one is for another question. Okay, wait. Um, okay, I just use this diagram to show. Alright, so this one the answer is A. So this one goes outside from the paper, north and south. So the force will go upward. Okay, so this one the north and south. Okay, and then the current goes into the paper, the force will move downward. So usually when the catapult field going upward, going downward, the force will go upward. So it's like opposite. Okay, so like this one, if the force going downward, the catapult field will move upward. Okay, so it's like a opposite. Okay, so the answer this one is A. Okay, and then paper 2. So for this one, so this is the drawing. You have to draw the catapult field. So this is the answer. Okay, you just change the polarity of the magnet. Okay, before this, for the question before, okay, question before, this one is not and this one is south. Okay, for this one, right, you just change the polarity. This one is not and this one is south. Okay, so this is how you want to draw the catapult field. Okay, so north and south. So I already show the how to draw. So this one is north to south. Okay, the magnetic field for the permanent magnet. Okay, this one the current goes outside from the paper. Okay, go out from the paper. So should be uh wait outside. So this one is anti-clockwise. Okay, anti-clockwise. So this one using right hand grip rule. Okay, so this one is going inside the paper. So this is a clockwise. Okay, so this is clockwise. So you can see at the bottom part, at the upper part here. Okay, so the direction is same. Direction for the magnetic field of the permanent magnet and the direction of the magnetic field of the current. The upper part is same. So it means it will curve upward here, right? So for this one, you can see at the below part here, okay, the direction for the permanent magnet, okay, is same as the direction of the uh, current, direction of the magnetic field for of the current, right? Both goes to the left, okay. So it will curve downward. So I already told you if the catapult field, okay, this one goes upward, so the force must be go downward. So when it goes downward, the force must be go upward. Okay, so this is how you want to draw. Okay, and then the next one. So this one using, okay, this one already answer, you already draw, and then you also already show the direction of the force here. Okay, and then you already label. So name the rule, okay, to determine the direction of resultant force. So this one you have to use the Fleming left hand rule. Okay. Alright, so the next one E. Okay, the reading of emitter in 7.1 is not uniform due to the incorrect shape of the magnet used. So in the space below, draw the correct shape of the magnet. Okay, so should be like in a concave, right? Concave shape. Okay, should be like this. Okay, so the why? Okay, so the next question, say give one reason for your suggestion. Okay, so the radial of the magnetic field is higher. So this one I already show you compared, okay, compared using this one, this type of magnet and the concave type of magnet. So you can see if the normal magnet like this, okay, you can see the magnet line is the shape is like this. Okay, but if a concave, okay, you can see at the center, okay, at the center, it focus on the center of magnet. Okay, it focus on the center of magnet. So the concentration here will the magnetic field here will be higher at the center here. Okay, so that's why we need to have this concave shape of the magnet. Okay. Alright, so the next one, okay, give one modification to the copper coil that can increase the turning effect. Okay, so you can increase the current or number of dry cell, okay, use stronger magnet. Okay, so that's the answer. Okay, you can choose one. Alright, for next question, what is the meaning of magnetic field? Okay, so magnetic field, the meaning of magnetic field is a region where a magnetic material experiences a magnetic force. So this is the answer, 1 mark. Okay, and then the 4 marks, the explanation. Okay, so explain how this electric motor is able to rotate. Okay, so the first one you can use a sentence, okay, a sentence to explain, okay, or you can draw, right? So I give you the answer if you write in a sentence. So the first mark is the current flows through the coil, okay, and then when the current flows through the coil, you know that the conductor, okay, the conductor will produce a magnetic field, okay, the conductor will produce a magnetic field. Okay, here. So when the current flows here, right? Oh, sorry, from positive to negative. Okay, from here positive to here. Okay. So when the current flows, so you know this coil, okay, this coil will produce a magnetic field since the current flows, right? And then at the same time also, the permanent magnet also will have their own magnetic fields here. So what will happen? So it will produce the catapult field. Okay. So when you catapult field, you know catapult field, so you know there also will be a force that will the force also will be produced. Okay. So the first explanation, okay, the current flows through the coil, 1 mark, and then the magnetic field produced by the current that flows in the coil will react with the magnetic field from the permanent magnet. Okay, so both of the magnetic field will react each other to produce a catapult field. Okay, and then the force will make the coil move and rotate. So 4 marks for the explanation. Okay, so if you don't want to use a sentence, okay, you want to draw, you can use this drawing also. Okay, so you can still get 4 marks. Okay, because you show the magnetic field, you show the magnetic field from the magnet, and then magnetic field from the current here, and then you show the force here. Okay, alright, and then maybe you can add some more. Okay, here let's say you use the Fleming hand rule. Okay, Fleming's left hand rule uh to obtain the direction of the force. Okay, so you can get 4 marks also just by drawing, or you can just write in sentence. Both also can. Right? Okay, and then the next one. So this is the essay question number 12. Right? Okay, so this one you have to write diagram 12.2 shows the design and characteristic of 4 moving coil loudspeaker. Okay, so this one you have to choose. Okay, so don't forget, okay, if you want to answer this question, you must put the answer in the table form. Right? So first one, okay, characteristic explanation. So we use the copper voice coil. So copper, why we use copper? Because it has a low resistance. Okay, it has a low resistance. Okay, and then the second one, okay, soft iron core. So why we use soft iron core? Easy to magnetize and demagnetize. Okay, easy to magnetize and demagnetize. Okay, and then the third one, okay, must have a dust cap. So this one is to prevent dust to enter the coil. Okay, and then the last one is use a steel horn. Okay, so long lasting. So last we have to choose, right? So I choose S because it has a copper voice coil, soft iron core, and it has a dust cap and steel coil. So total mark is 10. Okay, so this is an example, essay question for chapter 8. Okay, so the next one is a calculation. Okay, 5 marks. Okay, so energy transformation. So the question said diagram 12.3 shows a load of mass 9.0 is lifted using an electric motor. So the electric motor rotates at 6 volt of voltage is supplied. Okay, so the energy transformation. So of course the first thing the energy that we'll have is electric energy. Okay, so electric energy and then electrical energy. So after electrical energy, of course, the load will move. So kinetic energy. So move upward, right? So from the kinetic energy, it will change to gravitational potential energy. Okay, so this is the answer. Alright, and then the last one. Okay, so if 1.5 ampere of current flows in the electric motor for 2 minutes. Calculate the electrical energy of the motor. So this one you have to use the formula that we learned in chapter 2, electricity. E is equal to P T, right? E is equal to P T. Okay, but since, right, they didn't give you, the question didn't give you the power, okay, so you can use P is equal to V I. Okay, so you change P is equal to VI. So V already given the question 6 volt, right? So the current is 1.5. Okay, the time must be in seconds. So 2 minutes you have to change to second to 2 times 60. So you got 120. So you just multiply all, so you got 1080 joule. Okay. Alright, the next one, the next one is if the efficiency of the motor is 85%, so how high can the motor lift the load up within 2 minutes? So the formula for efficiency is output divide by input, okay? Okay, output divide by input times 100 equals to percentage. Okay, so in this question, they already give you the percentage here. Okay, so you mean you have to find the output. Okay, so the input is this one. Okay, the electric motor energy. Okay, so the output is equal to 1080. Sorry, output divide by 1080 times 100 is equal to 85. Okay, so this one you just change using mathematics. Okay, you calculate and then you got the output is 918 joule. Okay, so you know that energy cannot be energy can only transform, right? From, let's say, so this one electrical energy transform to the gravitational potential energy. So we assume that 918 is actually the gravitational potential energy. So mgh. So the mass here already given in the equation, right? 9 kg. Kg is a gravitational 10. Okay, then the height is 10. And the height you want to find, okay, equal to 918. So you got the answer H is 10.2. Okay, so far is it okay? Did you check your answer? Any problem? Okay. So this one, paper one is actually, the next part is we just want to do some revision. Okay, so I give you the answer, right, for the question paper one, right? The question paper one. Okay, so this is the MRSM question 2018. So I hope you already already did it. So we can discuss the answer here. Okay, the first one, right? Which instrument used to measure potential difference? Okay, so this is a thermometer. This one is spring balance. So thermometer is to measure temperature. This one is to measure weight. Alright. And then this one is a ticker time. Sorry, ticker time. No. This one is stopwatch. Sorry. So stopwatch. This one is to measure time. So this one is a voltmeter to measure voltage or potential difference. So the answer is D donkey. Alright, for number two. Okay, so the following are three readings. The following are three readings S, Y, and Z obtained from three different measuring instruments. So which are the correct measuring instrument to obtain reading X, Y, and Z? Okay, you see the X first. So the X you see is 1 decimal point in meter. So this one must be measuring tape. Okay. And then Y is 3.56 mm. So usually the instrument that we learn that using mm is micrometer screw gauge. Okay. So because micrometer screw gauge, the sensitivity, right, is 0.01 mm. Okay, so 2 decimal point mm. Okay, so this one is micrometer screw gauge. Okay, for Z, okay, so in cm, okay, but 2 decimal point. Okay, so this one is a vernier calipers. Okay, so the answer should be D donkey. Okay, this one the answer should be D donkey. Okay, number 3. Okay, number 3. Okay, diagram 1 shows a boy and his uncle sitting on 2 identical beach balls. Okay, so which hypothesis can be made from the situation? So hypothesis, if in a physics, so hypothesis is the higher of something, the higher of something like that, right? Or the lower of something, or this is a relationship, right? Okay, so the first one, the depth of ball it must depend. So this depends is actually inference, right? When you write the experiment for section B, paper 3, so if inference must have the word depend. So this one is inference. Okay, the smaller the total mass, the deeper the ball immerse. So this one is, if this one is hypothesis but it's wrong. It's supposed to be the higher the total mass, the deeper the ball immerse. Okay. And then the volume of water displaced is affected. Okay. So affected is also using in the inference too. Okay. So both A and C is actually inference. Okay, B, and then the next one, the depth of ball immerse increases when the total mass increases. So this one is the correct one. Okay, so the answer is D donkey. Okay, so you have to make sure what the question one, whether hypothesis, inference, right? Okay, the next one, number 4. Okay, number 4. So diagram 2 shows a track of Kuala Lumpur Fun Run 2018. All runners start at M and end at P. Okay, so this is the diagram. So I already draw for you. So this one is actually use the theorem Pythagoras. Okay, so this one is 10, right? Sorry, this one is 10. Okay, so this one is 2, so this one must be also 2. Okay, so you draw a triangle here, right? So 6, this one is also 6. So 6, 8, and this one should be 10. Okay, so asking you to find the displacement. So displacement is the shortest, okay, the shortest distance. So should be from here to here. So you want to find, you make a triangle here. Okay, so 6, right? This one is 8, and then so this one should be 10. Okay, so the answer is B, boy. Okay, number 5. Diagram 3 shows a graph of displacement against time. So which of the velocities from the graph section is correct? So want to find the velocities from displacement against time graph. So you should know that the gradient of the graph displacement against time is equal to the velocity. Okay, so how you want to know the gradient? So you can draw a triangle here. So I already made here the triangle. So this one, if you draw a triangle here, you can see the triangle is, the size of triangle is same. So means the gradient is also same. Okay, so the gradient same, you already know that the gradient of this graph is equal to the velocity. So when the gradient same, the velocity is also same or uniform. Okay, so this one you cannot make a triangle from, you cannot make a triangle here. So the gradient is 0. So the velocity is also 0. Okay, for this one, when you draw a triangle, the size of triangle become bigger. So means the gradient increase. So the velocity also increase. So the answer is B, boy. Okay, B, boy. Alright, for number 6. Okay, so diagram 4.1 shows a coin on the top of a loop. Okay, diagram 4.2 shows the same loop is knocked by a pencil and the coin drops into a jar. Okay, so which physics concept is involved in the situation? So this is called inertia. Okay, inertia. So means the coin doesn't want to move, right? Doesn't want to move. The tendency of an object, right? To oppose. So means it oppose the coin oppose the movement from the loop. Okay, so the answer should be A. And then number 7, diagram 5.1 shows a trolley with luggage being pushed with force F. So diagram 5.2 shows the trolley with more luggage being pushed with the same force. So what happened to the acceleration of the trolley? So you use the F is equal to ma. Okay. So when the mass is increased, what happened to the acceleration? The acceleration will be decreased. So the answer should be A, number 7. Okay, number 7 is A. Right, number 8. Okay, diagram 6.1 shows Fazli driving a car. So diagram 6.2 shows an airbag inflate rapidly during a collision. So the airbag is designed to reduce momentum, no. Increase impulsive force, no. Okay, so lengthen the collision time. Okay, so the answer is C. Okay, when the time is increased, the force is decreased. Okay, you can check your answer. Okay, until from until question number 8, is it okay? Any questions? Okay. Right, number 9. Okay. So diagram 7 shows a load of 250 kg is hung by two cables. Okay. So this is the tension force. Okay. So what is the tension of the each cable T? So this one you have to use the um sine cos. Okay. So I already draw. Okay. I already draw the force the triangle. Okay. For you. So this one you divide the angle first, 30 degrees here and 30 degrees. So this one is a weight. So weight move downward, okay, because of the gravitational force. Okay, so I took this side only, okay, only one side. Okay, so I draw it again here. Okay, so weight is 2,500. Okay, what W is equal to mg, right? So 250 times 10. Okay, change to Newton first. Okay, so the answer is 2,500. So this is the weight. Weight is 2,500. Okay, and then, okay, so this is the tension. So you want to find T and the question give you W. Okay, so this one is adjacent. Okay, this one is hypotenuse. So cos, right? So cos 30 is adjacent to 2,500. You divide by 2t. Why 2t? Because there are two tension here. So you only want to find one. Okay. So the next one is only maths. Okay, you calculate. So you got the answer 1443.38. Okay. Okay, so the answer is B. Okay. Number 10. Okay, number 10, which situation experience forces in equilibrium? So forces in equilibrium means the net force is 0. Okay, so net force is 0 means the object, if it move, okay, it move with a constant velocity or it will be stationary. Okay, so you find the which answer gives you the uniform velocity or in stationary. So the answer should be D. A ship floating at sea. So the answer is D. Alright, number 11. Okay, which situation shows no work being done? Okay, so uniform velocity or constant velocity. So the answer is C. Okay, the answer is C. Alright, for number 12. Okay, for number 12, diagram 8 shows a 2 kg load suspended on two different springs, P and Q. Both springs have the same initial length. So what is the difference between spring P and Q? The diameter. Okay, the diameter of spring is different. Okay, so this one is much bigger than this one. Right? So you know, okay, the factor that affecting the constant of spring, right? The stiffness of spring. Okay, so the factor that affected the stiffness of spring, the first one is the length. Okay, the shorter the length of the spring, the more stiff the spring. Right, and then the second one is the diameter of the spring. Okay, so diameter is here, diameter of the spring. Alright, so the diameter of spring, if the diameter is smaller, okay, the spring will be stiffer. Okay, and then the next one is the diameter of the wire of the spring, means the thickness of the spring wire here. So if a is a thicker, is it if the spring is thicker, okay, it means the spring is more stiff. Okay, so if we compare this one, okay, so this one's diameter is smaller, right? So means the P is more stiff. So if it is more stiff, means it cannot extend too much compare than this one. Okay, so means the length here will be, the length of P will be shorter than Q. So the answer is A. You see the length here? Okay, the X is equal as actually the extension of the spring. So this one, you see the P is more shorter than this one. Okay, so the answer is A. Okay, number 12, the answer is A. Okay, alright, the next one, number 13. Okay, diagram 9 shows a tractor on muddy ground. Okay, so why does the tractor has a wide tires? Okay, so to reduce the pressure on the ground. So P is equal to F divided by A. Okay, use that formula. So the answer is C. Right, number 14. So diagram 10.1 shows 2 points W and X in water. Okay, diagram 10.2 shows 2 points Y and Z in cooking oil. Okay, so W and Y, you see it on the top of in the surface of the water. So in the surface of the water, there is only one pressure that acting on it. That is atmospheric pressure. Okay, so at W and Y, the pressure is same because only atmospheric pressure acting on it. Okay, but different with X and Z. There are two types of pressure acting on it. First, the atmospheric, of course, and then the second one is from the pressure inside the water itself. Okay, so the answer is C, number 40. Okay, so PW equals to PY because atmospheric pressure only acting on it. Alright, so for X and Z, of course, you know the water has higher density than cooking oil. Okay, so when the density is higher, means the pressure of X must be higher than Z. Okay, so the answer is C. Okay, number 15. Okay, what is the value of H if the pressure of the gas is 82 cm? Okay, so this one means the gas is higher than atmospheric pressure. So P atm plus H, okay, equal to 82. So P atm is 76, right? So 76 plus X, okay, and then equals to 82. So you want to find the H here you just minus 82 minus 76. So you got 6 here. So the answer is B. Okay, number 15, the answer is B. Okay, number 16. Okay, so which principle related to the forklift truck? So this one actually using a piston. Okay, so piston means using a Pascal principle. Okay, Pascal principle. So the answer is A. Okay, until then, is it okay? Alright. Okay, the next one, number 17. Okay, which statement is correct about the hydraulic brake system? So hydraulic brake system using the Pascal principle. So what Pascal said, the pressure is transmitted equally or uniformly. So you find the statement, okay, which the statement? So pressure change with depth, no. Okay, this one is not Pascal. Okay, pressure change with the fluid velocity. Okay, this one is a Bernoulli, not Pascal. So pressure is transmitted equally in the fluid. So the answer is C. Okay, so this one is Pascal. Alright, the next one, number 18. Okay, diagram 14 shows a wooden block with a height of 4 cm is pushed into the water. So which of the graph shows the relationship between volume of water displaced V and depth of sinking H? So the answer is D donkey. So when you push, of course, the volume of the water will come out, right? So the volume will be increased here. Okay, and then after it fully immersed in the fluid, in the water here, so there will be no more water flowing outside. Okay, so it will be no change here. Okay, so the answer is D. Okay, so that one, number 18. Alright, number 19. So this one chapter 4. Okay, shows a thermometer is used to measure the temperature of a patient. So which concept explains the working principle of the thermometer? So the answer is thermal equilibrium. Okay, the heat from the patient transferred to the thermometer until both, until it become same. Okay, until it reach thermal equilibrium. Okay, so the meaning of it the meaning of the thermal equilibrium is uh, the net rate of heat transfer is 0. So that's the meaning of the thermal equilibrium. So for the thermometer, the heat transfer to the thermometer, the heat from the patient transfer to the thermometer until both the temperature of the patient is same as the temperature of the thermometer. Okay, so you use the thermal equilibrium. Alright, number 20. Okay, so which pair is correct for both situations? So you can see here, right? This one is the ice melting, right? So when the ice melting means it change the phase, right? From the solid to liquid. Okay, solid to liquid. Okay, and then this one, water boiling. So water boiling means temperature change. Okay, but there is no change of the phase here. Okay, so this one, if it involves the change of phase, means from the gas to liquid, solid to liquid, or liquid to gas. Okay, so it must have it is a latent heat, right? Latent heat. This one, okay, this one doesn't change and the phase is not changing, not like water to the gas. So the temperature is changing, okay, but the temperature is changing. This one is a specific heat capacity. Okay, this one the only the change of phase Okay, from solid to liquid. So this one is called a latent heat because a change of phase here. So this one only the temperature increase, but there is no change of phase. So this one is specific heat capacity. So the temperature of melting ice, right? So the temperature is constant, okay? And then this one, the temperature is increased. Okay, so the answer is D, boy. Okay, so you have to remember if there is no change of phase here, okay, from solid to liquid or liquid to gas or vice versa, okay, then this one is to be latent heat. Latent heat means no change of temperature. This one, no change of phase here, okay, but the temperature is changed. So this one is specific heat capacity, right? The next question, number 21. So investigate the gas law. So this one thermometer, you know, must if there's involved a thermometer, so must be changed in temperature. So of course, boys, this is not Boyle's law because Boyle's law is pressure and volume, right? And then the next one, it used the air trap here. So the trap air is actually is a volume. Okay, we calculate the length here. So the length here, the trap air is actually the volume. So volume and temperature. So that one should be Charles' law. Okay. If pressure, they must use the um Borden gauge. Okay, the Borden gauge, then you use know that it measure the pressure here. So there is no Borden gauge here, so means the pressure is not involved in this experiment. Okay, so only volume and temperature. So Charles' law. The answer is D, bond. Okay, number 22. Okay, so this is a light chapter. Okay, diagram 18 shows a light rays propagates through a glass block. So the refractive index of a glass is 1.5. So this one, what formula you should use? Okay, because already give the refractive index, right? So you must use the N is equal to sine I over sine R. Okay, I is the incident ray. This one is from the refracted angle. I is the incident angle, and then this one is refracted angle. Okay, so I is 60. Okay, why not 30? Because this is not incident angle. The incident angle must be from the normal line and the incident ray between it. So this one should be the incident angle. So this one is 90 degrees, right? So this one is 30 and then this one should be 60. So the I is 60. Okay, so I is 60. Okay, then you just use maths. Okay, calculate. You got 35.26. Okay, this one you should use the sine inverse. Okay, so you got 35. Okay, so the answer is C. Alright, number 23. Okay, binocular. So this is the total internal reflection. Use the physics concept total internal reflection. Okay, so I already draw the light ray. Okay, so because total internal should be like this. Okay, right back. Okay, so this is how you want to draw the ray diagram for the binocular. So the answer is D, donkey. Okay, from here, okay, reflect back. Okay, reflect back, and then suppose the triangle must be bigger than this. Okay, and then go here, and then go out again. Okay, so the answer is D, donkey. Okay, the next question. Okay, number 24. Okay, what happened if the image, if the object is placed at distance less than focal length? Mean U is smaller than F. Okay, so I draw for you so you can see. So this is the object. So less than F, right? So this is the object. this is the position of the object. I is less than F. Okay, so you draw a ray diagram. Go here and then go center here and then you make it longer. Okay, so you can see the image here. Okay, so the image here then show the image is visual, right? Because for the mirror, if the image is behind the mirror, this is visual. Okay, but for lens, okay, it opposite. Okay, if the image behind the lens, it is real. Okay, but if the image in front of the lens, okay, it is a visual. So this one, the drawing, when I draw, okay, you can see the image is in front of the mirror. Okay, so it is visual. So the answer is A. Okay, and this one, the diagram is also the drawing for the magnifying glass. Okay, alright, the next one, number 25. Okay, which A, B, C or D is the focal point? Okay, so this is the concave lens. So when you draw, okay, you draw straight line from here. Okay, then it will go back here, right? And then should make it longer this side. So it will come back to F. Okay, it will come back to F. So the F is where? Is at B here. Okay, go back. Okay, go back here and then you make it longer here. Because it's a lens, so lens use refraction. So however, all the light rays should be out from the lens. Okay, so that's why even you draw it, okay, draw it, go back to B. Okay, you still have to make it longer. Okay, until it go out from the lens, because lens is a reflection. Okay, using the refraction of light. So the answer is B. Alright, number 26. Which statement is correct about longitudinal wave? Okay, the speed of wave is 3 times 10 power of 8. So this one is actually the electromagnetic wave. Okay, an electromagnetic wave is not a longitudinal wave. That one is a transverse wave. Okay, the wave can propagate through vacuum. Okay, this one is also the properties of the electromagnetic wave. Okay, and then electromagnetic wave are longitudinal wave. No, it is a transverse wave. Okay, the vibration of the medium particle is parallel to the direction of the propagation of wave. So this one is correct. Okay, longitudinal wave is a parallel to the direction of propagation of wave. Okay, but for transverse it is perpendicular to the direction of propagation of wave. Okay, that one number 26. Okay, number 27. So direction of wave propagation. So this one is a reflection of wave. So you know the properties of reflection of wave, all is not changed, like velocity, velocity, frequency or the wavelength. Okay, it's not changed. The only thing changed is direction of propagation. Okay, so reflection and the diffraction, it has the same properties. Okay, except diffraction, the energy will decrease. Okay, after it diffract. Okay, but for the reflection here, all is not changing. The velocity, sorry, the speed is not changed. Okay, and then the wavelength is not changed and the frequency also not changed. Only change is direction of propagation. So that is the reflection of wave. Okay, so the answer is D, donkey. Okay, next one, number 28. Okay, so this one use what phenomena? What wave phenomena? So since the depth is changed, right? So this one is refraction. So this one, the depth is higher than this side. Okay, so the wavelength here should be longer. Okay, should be longer than this side. So the answer is A here. Okay, number 29. So this is diffraction. Diffraction of wave. So diffraction of wave, I told you before, same like reflection. Okay, only one thing, okay, is the energy, right? The energy will be decreased. So the answer should be B boy. Alright, number 30. So this one is interference. Okay, interference. Hmm. So I already so the calculation here using lambda is equal to AX over D. Okay, so A is the distance of the loudspeaker. Okay, so X is actually, okay, from loud to loud or soft sound to soft sound. So this one is given from loud to loud, right? So you should see how many X here. 1X and 2X. Okay, so but the total distance is 4. So you want to find 1x, so you just divide 4 divide by 2 because there's 2x here. 1x, 2x. So 2x equals to 4. So x equal to 2. Okay, so I divide here. And then D is the distance, okay, distance of the loudspeaker and to the people that hear the sound here. So this is 10 meter. Okay, so just substitute it and calculate. So the answer is B boy. Okay, number 31. Okay, diagram 26 shows a singer plucking his guitar. Okay, high pitch produced by the guitar is due to the high frequency. Okay, pitch depends on the frequency. Amplitude, loudness depend on the amplitude. So the higher the amplitude, the higher the loudness of the sound. Okay, so the answer this one is C. Okay, number 32. Okay, number 32, the answer is C. This one you have to remember. Okay, so this one is a gamma. Okay, this one is the visible light. Okay, so 27, 32, the answer is C. Okay, 33. So this one chapter 7 already, electricity. So which electric field pattern of positive charge is correct? So positive, the line goes outward, right? Go outward. So the answer is A. Okay, positive, negative goes inward. The line goes in like that. Okay, that one is easy. Number 34. Okay, so this one is diagram 28 shows a voltage current graph for a conductor. Okay, which statement is correct about the graph? So the conductors obey Ohm's law, no? Because if Ohm's law should be directly proportional, straight line. Okay, the conductor is a copper wire. So copper wire usually obeys the Ohm's law. Okay, so resistance increase as the current increase. Okay, that one. Okay, for the graph V against I, okay, the gradient is equal to the resistance. Okay, the gradient of the graph is equal to the resistance. So you can see from the graph here, okay, when you draw a triangle here, the triangle become bigger, right? So means the gradient is increased. So when the gradient is increased means the resistance is also increased. Okay, so the answer is C. Okay, the answer is C. Alright, number 35. Diagram 29.1 and 29.2 shows three identical bulbs in two different arrangement circuits. So this one is parallel, this one is series. Okay, which pair is correct is one of the bulbs is faulty. So for 9.1, 29.1, the current still can flow, right? Let's say this one cannot use. Okay, so it still can flow for the second bulb here and also for the third bulb here. Okay, so this one it can still can light up. Other bulbs still can light up. Okay, but for this one, let's say this one is broken. Okay, so positive to negative. So it cannot pass through here because this one already broken. The current cannot pass through here because this one is broken. So mean the current cannot complete the circuit here. So the bulb will not light up. So the answer is D donkey. Okay, number 35, D donkey. Okay, number 36. Okay, diagram 30 shows a closed iron label 240 volt and 1200 watt. So which is the amount of electrical energy consumed in 1 minute? So this one E is equal to PT. Okay, already give you the power, right? So the power is 120, 1200. So the time is in second. So multiply by 60. So you got 72,000 joule. So the answer is D. Okay, number 37. Okay, this one you have to use the no need. Okay, just asking you which of the following will decrease the distance between the magnetic field line. So whether you inverse the terminal of dry cell. So if you inverse, let's say this one, this side is positive, this side is negative. So you just reverse it. So this one is positive, this one is negative. So the current will flow from here to here, right? So if using right hand grid rule, okay, the direction is changed. Okay, but the magnetic field still same. Only the direction here will change because of because the change of polarity of the dry cell here. Okay, so increase the number of dry cell, no. Okay, this one will increase the magnetic field line. Decrease the thickness of the connecting wire. So if the thickness of the connecting wire decrease, mean the resistance increase. So if the resistance increase means the current will be lower. So the current lower, the magnetic field also here should be decrease. So the answer is C. Okay, decrease the thickness, resistance increase, current decrease. Okay, so the magnetic field here also will be decreased. Alright, number 38, the speed of direct current motor can be reduced, okay, by increase the resistance of coil wire. Okay, this one I already explained. Okay, same like number 37. Okay, alright, number 39. I think the last question, right? Number 39. Okay, this one you have to use the right hand grip rule. Okay, so first positive to negative. Okay, positive to negative. So the current go downward, right? So when you use your right hand grip rule, okay, so you want to know the polarity, you use the right hand grip rule. So you can see because it's go downward like that, okay, so your four fingers, okay, we go downward like that. So Q is wait, positive to negative, right? Positive, negative, so it going downward like that, sorry. Going downward like that. So this one should be north and then this one should be south, right? This one should be north and then this one should be south because your thumb showing this side, right? So positive to negative, going downward like that. So your right hand, okay, so it should be downward like this. So this one should be north, okay, this one should be south. So different polarity of magnet, right? This one is south, this one is north. So the distance, the S will attract to Q, right? And then this one P will attract to N here. So the answer here is Q is north, P is south, north, south. So it moves. This is north, so north. So the answer is should be B boy. Okay. move toward the solenoid because it attracts different polarity. Okay, so the answer is B, boy. Okay, so I think until now because after that we didn't learn yet. Okay, any questions? Anything you want to ask? Why P is not not? Hmm. Wait. Okay. For this one, I will send you a video. Okay, to show why this one is not not. Okay, because it's hard to show from here. Okay, this one I will send the video to you. Okay, I will put the in the YouTube so you can watch there. Okay, for this question number 39. Okay, because this one you have to use the right hand grip rule. I will show video with my hand later. Any question then other than 39? Okay, so there's no question. Okay, thank you class. So for number 29, I will make a video and send to you later, okay? Okay, thank you class. So see you tomorrow. Make sure before 7:15, okay?